So engine bleed, why do we need bleed? We need high pressure air, okay, to be able to start the engines. We also need high pressure air to operate the packs that eventually gets pressure regulated and temperature regulated and put into the cabin as conditioned air. We also use high pressure air to pressurize the water tanks inside the water tank inside the aircraft for the potable water, so that the taps can have some pressure. Okay, and that's why we need the bleed pressure, so to speak, so we can um, get bleed through the engines themselves or the APU or a specific high power air HP ground supply on the ground as required. If, for example, the APU wasn't working, so on the ground, the engines are definitely not working. But we need to condition the cabin because I'll give you the scenario. There's 180 passengers on board. A small paperwork issue has arisen. There's a passenger that can't find his seat number or whatever. So we're sitting on the ground for 45 minutes now. It's 40 degrees outside. We need to have the air conditioning on. For the air conditioning through pack 1 and pack 2 to operate, it needs high pressure air. For the high pressure air to come to the packs, it needs a supply from somewhere. So on the ground, engines off, the APU is working. If the APU is working, it will supply the 30 odd PSI of hot air that will come to the packs. Remember we said on the packs we get hot air around about 25, 30 PSI, 200 degrees Celsius. Okay, that's what comes to the pack. And through the cross bleed valve, I can, with one supply, offer air to two packs. Okay, on the ground. Let's say the APU is also US. If the APU is also US, I can provide HP ground air to supply the packs, but I usually conserve this. To help me to provide the high volume air that I need to start the engine, which will then be able to provide bleed to the cabin. Okay. All good? So the APU itself is a power generator. We will move away from the bleed now and talk about its electrical generation properties. I'm on the ground. The engines are not running. Okay. I sometimes have the APU on, which has its own generator supplying electrical power. And if I don't have the APU on, or the APU is broken, or I'm not allowed, some airports, especially in Europe, a lot of the environmentally friendly airports now don't allow the use of the APU until 15 minutes before departure. Then you require an external power to be connected to supply your electrics. Okay, so I've got APU supplying bleed on the ground and electrical power on the ground or in the air as and when required. Here is the APU in its box. Here is the air inlet where it's usually closed. By closing it makes this, it's aerodynamically smoothens the area here, the underside of the aircraft. When commanded to start the APU, the first thing that happens is the air inlet opens progressively and lets the air come in here, okay, and combusted, which will turn different components, including a generator and a bleed valve. The bleed valve will then send the air in to the aircraft. Okay, and the electrical generator, this thing here, starter generator, will send the electrical, the three-phase power into the aircraft, and all the air from the engine operation will be expelled aft through the muffler here. Okay, this is how it sits in its box. It's okay. It's a really it's a nice big box. If you're topping up the oil, it's pretty handy, it's convenient, it's not a bad thing. We do have, as I said at the beginning of this, two different types of APUs. This is not a very high level, it's a level 1 course. So I'm going to put the two APUs up and just tell you the main difference. So this is the one. The idea is air gets sucked in, gets turned, gets compressed, gets ignited. And by igniting, we can then, through a gearbox, through an accessory gearbox, turn a generator and cause bleed air. Okay. So, and that's the idea of these things, is to create electrical power and air. The electrical power is the same on both APUs. This is the Honeywell one. Okay, and the main difference is we have on the bleed side of it, we have a load control valve and the surge control valve. So it's a bleed valve with a surge function. So remember we said when we're going to start the engines, we need around about 35 psi. So the function of this is such that the air comes out here, the hot air, and let's say 40 psi is coming out. This load control valve is set at 30 psi because it's commanded through the electronic control box, which is a FEDEC, to provide its logic say you have to provide 28 psi in the cabin until you're gonna start the engines. Then we're gonna pump up the load. But at the moment, you need to provide 28 psi of air in the cabin. So the load control valve is commanded to open to allow 28 psi through into the cabin or to the packs. However, the engine is producing 40 psi coming out. So if it's producing 40 psi, 29 come this way because that's how the valve is regulated, and the rest of it goes out the surge valve into the back of the engine and out to the exhaust. Okay, so the surge control valve takes any surplus air that's not required for bleed and takes it overboard. Okay, so that's the one system in the bleed circuit, the one APU. The other one, all the functions are the same, but this valve is one unit now, and it has a dual function. Okay, it does the bleed supply and the surge at the same time. It's one valve which gets commanded to move, to make the ratio of how much air you want going this way into the aircraft and how much air needs to be ducted overboard because it's too much. And those are the two main differences of the two APUs. The other one was the Garrett. This one is the APIC APU. And all the rest of the functions, the starter does the same job, the AC generator does the same job, the cooling fan does the same job, the fuel control unit and the lubrication, so this fuel and oil all do the same jobs. The only difference in the design is how the air gets delivered, the high pressure air gets delivered into the aircraft. Okay, so these are all the controls to do with the APU. We already talked about an APU in a fire. We already talked about the APU in a automatic fire extinguishing scenario. where would this be? It would only be used by maintenance, and therefore it's at the maintenance panel, right at the back of the aircraft. Okay, we said pilots don't need it. What they do need every day, and that's why this is readily available here, right in front of them, is the APU master switch and the start push buttons. Okay, so the idea is if you're going to use the APU, you're going to switch it on. You push on the master. The master engages all the circuits, tells its own FEDEC, which is the APU. What's it called? APU. Uh, uh, Electronic control box, the ECB. That's what it's called, which is the FEDEC for the APU. Hey, I'm going to start now. Get ready. You power it up by using the master switch, and when it's ready, you press the start, and that initiates the APU start. So the starter will engage to turn the motor. The motor will suck in air. The air will get compressed and then combusted, and then shoot out the back as hot air. And the process has started. The motor started turning. At some point, the starter disengages because the engine is self-sustaining now. It's sucking in fuel and compressing the air and igniting it, and everything's the engine is self-sustaining. And at some point, it reaches a stage where the bleed is nice and hot and available, which can be supplied to the engine. And also the electrics are running, the generator is running at a right speed where it can deliver 200 volts at 3 phases onto the aircraft systems. Okay. We talked about the fire warnings of the APU already. Okay, so we have this. It's a remote one, and there are options, guys. You can have this same scenario. You can have it on the refueling panel. In fact, when we did the refueling panel, we didn't talk about it because APU wasn't there at the time. But this similar arrangement can be on the refueling panel as well, so that you can, if you're here refueling and the APU catches fire, the time it will take you to run here, go onto the aero bridge, up the stairs, into the cabin and into the cockpit and put the APU out, the APU would be dust. So if, for example, there was an APU fire, you could extinguish it or shut it down, at least from this position here, to save you the delay in going up into the cockpit. The APU has a specific dedicated page. Okay. It's pretty boring and quiet and lame when the APU is shut off. But when the APU is up and running, it usually shows the temperature of the engine. It shows the rotation, the speed of the engine. It's usually fully operational. APU will be at 100% rotation, and will usually, depending on the load, be around about 450 degrees. And then as you add loads to it, it will progressively get hotter and hotter. Okay. And it shows you the generator here has a 26% electrical load, and it's providing 115 volts, 400 hertz to the aircraft, which is what you need. It's also providing bleed because the bleed valve is opened, and it's at the moment it's 35 psi being delivered to the aircraft. Okay, these are not usually there. These are there when these situations arise. And of course, because I have an electronic box, the ECB, I can test the APU and all its functions, any shutdowns it had, any over temperatures, any conditions it's had can be monitored and tested and troubleshot and printed out. And yeah, it's just like any other LRU or any other component on the aircraft. It is a fully fledged engine, okay, and an independent engine, and does its job really well. Sometimes, depending which APU you've got.